shows the two types of questions I think are great.
Good morning, everybody. Good morning. I realized 2 minutes ago that I had forgotten to post the topics list. So I just did that, which is why we're starting 2 minutes late. So we're going to go over those, kind of what all that means. I want to answer every question today that I can answer about like the mechanics of the exam and what you can expect and how that's all going to roll, all those kinds of things. I don't think we'll take up all of our time today for class, but we'll see how far we get. We'll probably talk about cheat sheets and all that sort of stuff, right? So I posted this just, like I said, just now. So this is like breaking news, right? And here are the topics, items. There are 7 questions on your exam, okay? And there better be 7 topics there, right? 1, 2, 3, 4, 5, 6, 7. So I did a good job there, right? Now, whether these are actually the topics or not is a different story. No, I'm pretty sure they are. Okay? So let's talk about these topics first, and then we'll get into the mechanics of the exam, right? So Gauss's law. Okay, first of all, and I'm not going to apologize for this because I actually think it worked out better in your favor. How many chapter 21 questions are listed in these topics? None. It turned out that as I was going through all the many questions I could have asked you, all the questions I've written over the years, new ones I was coming up in my head, that they were all harder than chapter 22 and 23 questions. Harder in the sense that they took longer. There was a lot more like vector things to keep track of. And I'm used to giving a 12-question exam where I've kind of got room to do that. And as I was paring it down and thinking about it, I decided, you know what? This test is going to be on chapter 22 and 23. I mean, frankly, chapter 22 is almost an exact copy of 21, isn't it? I can still see if you know anything about vector. Like I can test all the things that I need to find out that you know or not to meet the state's criteria for having gone through Physics 4B. So it turned out there are no chapter 21 problems on the exam, okay? It's all chapter 22 and 23. So Gauss's law conceptual, which chapter is that? That's 23. Okay, Gauss's law. Anything with Gauss's law is going to be chapter 23. This is a conceptual question, and I gave you some conceptual questions on the homework, but how do I ask a conceptual question about Gauss's law? It could be about flux, right? Just finding the flux through a surface, knowing what the flux is based on the charge enclosed. It could be things like the electric field inside conductors, right? What is the electric field inside of a conductor? 0 as long as it's in equilibrium, right? And everything is going to be in equilibrium for you for right now. So that Gauss's law conceptual, right? And then these are in no particular order, apparently. And then there's electric field integral setup. So what chapter? It's 22. Integral setup. What does that mean? It means that I'm going to give you a situation. And you know all the situations now. Let's name all the situations you could have. Rod. Ring. Disc, sphere, perpendicular bisector of a rod, sheet, right? That's actually Gauss's law. But that's like it, right? Cylinder, right? So like, that's it. It's going to be one of those things, right? And in this problem, I'll give you a situation, and I'm going to say, set up the integral only. Like once you get it set up, right, you've got the entire thing in terms, get your charge density correct and get all that figured out, right? Stop there. Don't do the integral. There's no time. Okay? This is one of my ways for you to save time on the exam, right? Set it up, don't do the integral. So you're going to have a question like that. Electric flux / Gauss's law. This is a chapter 23 calculation, right? You are going to be figuring out either a flux or using Gauss's law. Remember, Gauss's law is the integral you don't do the integral you do see, and sometimes you do the integral that you don't see, right? Electric field of a charge distribution. Okay, line, ring, disk, etc. That's like electric field integral setup, right? Where you may or may not have to set up the integral, because if you've got the electric field, say, of a ring written down on your page, you can just calculate what this, but this is a full calculation, right? Okay, so it's up to you whether or not you want to reinvent the wheel. But it's going to be one of those. Gauss's law. Okay, so different from electric flux / Gauss's law is a straight up Gauss's law, and I'm just telling you, you're going to have to integrate to find the Q. Use Gauss's law, and you've got a situation where you're going to have to integrate to find the charge enclosed so that you can then figure out what the electric field is. What do you mean? What?
Remember on the test last semester where you...
I forgot to put the topics right on the question. So I think what I might do is write them on the board, right? And we'll talk more about what's going to happen when we get in here a little bit later. Okay. I must have been really nice when I wrote this. Electric field of an arc of charge. I told you straight out what the problem's going to be on, right? Okay? So an arbitrary arc of charge. Starting at some angle, going to some other angle, not a complete circle, right? Okay? So you know, what are you going to want to put on a cheat sheet? The equation for an arc of charge. Again, so you don't have to reinvent the wheel. And then there were several problems in both chapter 21 and 22 where there was like an arrangement of a couple charges and like find where to put a third charge so that the electric field's 0, or find the charge that would make this situation 0. You've done that problem like probably 3 times now, right? So I figured let's put that one on the exam too. Any questions about these topics and sort of what you're going to be up against when it comes to the exam? Things you're just still not certain of, words I just said that didn't compute. For the summary sheet? Yeah, you get full page front and back. Yeah.
I guess it kind of relates to homework too. There's a homework problem where you've given dimensions of a room and the error is flux.
Oh, the shower? Yeah.
Are we going to have something along that lines as one of
I mean, that's charge enclosed in flux, isn't it? It won't be a shower this time. It'll be a toilet. No, it won't. It could be. Yeah, it could be. I mean, anything on the homework's totally fair game, right?
Well, then I have questions.
But there are some questions on the homework that don't make it into this list, right? So part of the study is to kind of go over the homework and see which of these line up with, that sort of thing. I thought you did have a couple of homework problems that involved arcs of charge, right? They were like quarter circles and semicircles and stuff like that. So, yeah. The electric field, yeah. So the thing here, let's see if I can cause some PTSD. There were several problems where there's like a charge here and a charge here, and they're like, where do you put the third charge so that the electric force on it was 0? And then in chapter 22, it was where the electric field is 0. And it's like, this was a, negative charge, and this was a positive charge of some kind. Okay? So can you put a charge anywhere between these and have an electric field of 0? No. No matter where you put a charge, it's going to have an electric field from this one pointing away, an electric field for this charge pointing towards it. Those are always going to have net electric field, right? So the only other choices are over here or over here, because on this side, negative q towards, positive q away. And over here, same thing but opposite. And so is it possible to get 0 here and here? Yes, but now we have to consider which of these charges has more charge, right? We want to be as far away from the biggest one as possible, because the distance, the bigger charge will be knocked out or canceled out by a bigger distance away to get the magnitude equal to 0.
That was one thing I was confused about. Since it's like an arbitrary charge that we don't know yet, are we supposed to just assume that it's positive?
Yeah, you always just start with a positive charge.
Okay.
Yeah. And I believe in these problems it actually doesn't matter if it's positive or negative. But does that answer your question? Yeah. So it was like that, right? And it'll be very similar to something like that. Any other questions on the topics? Okay, as you come up with questions, write them down. You can ask me on Monday. All right. There's some other things in here for you to read. I apparently didn't put them in alphabetical order. Integrity, honor, and a pledge. You'll be putting an honor pledge on the exam. Make sure that you understand it. So let's see. When you come in to the exam next Thursday, right? Keep wanting to say it's Tuesday because I feel like we're ready to go. But next Thursday. So I think maybe what we'll do on Tuesday is I'll just let you ask any questions you want. Yeah, we might start that today, and it'll happen a lot on Monday, but Monday's a good day for finishing up the homework. So on Thursday, right, you're going to come in and, pick your favorite seat. It's probably going to be the one you're sitting in right now since everybody's sort of claimed their spot, right? I'm going to have enough exams to have one at every spot out there. Okay, minus my sanitized ones up here. You come in and I'm going to have you put every device that connects to the internet. Insulin pumps can stay with you. It's going to go in your bag, turn it off so it doesn't ring or buzz or do any of that kind of stuff. Smartwatches, earbuds, you know the drill. And then I'm going to have you put your bags up here. Right, just along the front. We have a lot more room in this one than we did the other building. And I'll just run an eBay auction while you guys are taking the exams. Right, we'll see if we can get anything for your bags. No, I do shop around though to see like what backpacks are good and stuff like that for my own benefit. And then so what should you have at the table with you? A cheat sheet. Calculator, something to write with, okay? That's all you should have. As you can see, you guys are pretty sardine-ish out there, right? I mean, it is kind of, you're almost bumping elbows out there, aren't you? So do your best to keep your cheat sheet and your test to yourself, right? None of this, I'm working on this thing, I'll just push my cheat sheet over there, yeah, right, okay? So, and I'll walk around and kind of shove your cheat sheets around and things like that. But yeah, there will be 2 different versions of the exam. One will be printed on green paper, one will be printed on blue paper. They're the same level of difficulty. The rule is you can't be sitting next to somebody who has the same color test as you, right? So we're going to go through an exercise of how do we hand them out? So, right, okay. My 4A students did good this morning. They had their first test this morning and they figured it out. So I have high hopes for you. You got to show up the 4A students, right? Okay. But they managed to get them handed out pretty quickly. And then away you go, right? 75 minutes, 5 minutes to freak out, and then 10 minutes per problem, right? Thereafter. When you're done, you're going to take your cheat sheet and your exam. You're going to come up towards the front. I'll have a stapler ready to go. You'll staple your cheat sheet onto the back of your exam, lay it down face down in the bucket, and then you can go. Don't forget your bag. Sometimes people forget their bags. So that's like the sort of mechanics of how it'll run and the environment. This will be this room, right? And I'll wander around and, I don't know, look threatening or do something, right? During the exam to freak you guys out. Yeah.
What are the cheat sheet requirements again?
As long as it's no bigger than 8.5 by 11, I don't care.
8.5 by 11.
Yeah.
Print it?
Yeah.
Okay.
Yeah. Do I have it here? I got to show you guys this one. Don't tell the 4A students. Where did it go? One student came in this morning and said, "Hey, Mr. Balogh, is this okay?" Showed me their cheat sheet. Oh, here it is. Here it is. Said, "Mr. Balogh, is it okay if I have this on my cheat sheet?" It says, "Who needs Newton when you have Balogh?" And then it's got a picture from the website. I'm really freaked out because it's a smiley face with a rose in its mouth. And then a picture of me in my hat, my vector hat, right, that they must have snapped while I was lecturing, right? Right? Well, yeah, the printer didn't do a good job. There was other stuff on their cheat sheet, right? But, like, I'm kind of weirded out now. So.
That's so funny.
Yeah. So, yes, you can put anything on your cheat sheet. My constant answer to what am I not allowed to have on my cheat sheet is you are not allowed to have a copy of the exam you are about to take. If you do, you are a time lord, and I've got questions. But beyond that, right, you can put anything you want, okay? Including pictures of me. Some people have too much time in their lives. All right. Since we're talking about cheat sheets, do you want to go over stuff maybe that should go on your cheat sheet or like? Okay. All right. So let me kind of get rid of this. All right. I got a blank page, and I'm ready to use it. Yeah.
Is there going to be any like multiple of L problem that's going to ask?
Multiple of L. You guys love those problems, don't you?
No. You gotta find this, and then you gotta find it multiple of a distance.
I don't remember. It wouldn't even register as being different in my brain, so that's why I can't remember.
Like the radius is like 2.5 R.
Well, yeah, that happens all the time. That's pretty common.
The one we did together in
All right.
the one that's
Now, we've got plenty of time. I'm way ahead in this class, so I'm willing to do this. But generally, I hesitate to tell people what to put on their cheat sheets. Because who is the cheat sheet for? It's definitely for you, right? This is all about you, your brain. You might be good at remembering equations and not other things, or vice versa, right? And so really, I don't want to influence you too much, because the creation of a cheat sheet, it does two things, right? Number one, it does force you to review and summarize, doesn't it? Okay? Try to pull together the important information. The other thing it does is it's a safety blanket. It's a friend. It's the warm fuzzy during the exam, right? You can turn to it when you're freaking out, and maybe you've written it in such a way that could help jog your memory or calm your brain or something, right? So please do the due diligence of making your own, right? That being said, right, what would I put on my cheat sheet? Now, you got to realize that I'm coming with 23 years of experience in teaching this stuff, right? So my cheat sheet probably isn't going to be as full as, say, somebody else's. So I got to try to put my brain into the mode of, I don't know anything, I'm freaking out, right? All that kind of stuff. So let's start in chapter 23, okay? Based on the topics I showed you with the electric field, right? are there a set of, before we even get to equations, make sure that you put on your cheat sheet all of the metric prefixes from giga to nano. Let's just do that right now. Giga. A gigacoulomb. How many coulombs is that? It's 10 to the 9. Okay. Mega. 10 to the 6. Okay. And the symbol is capital G. The symbol is M. And then kilo. 10 to the 3. And that's a K. And then the one that sneaks in that's not a power of 3 is centi. Yeah, it's 10 to the 2. Centimeters, right? Where it usually crops up. Centi, 10 to the 2, and that's a little c. Okay, and then we get into the negative ones. It's micro, 10 to the minus 3, and that's usually, sorry, not micro, milli. They both start with M. Is it 1L or? Is it 10 to the negative 2, thank you. It's 1L, isn't it? This is not an English class. All right. I don't care.
As long as it's -3, it's okay.
It's not that one.
They both look wrong to me. Oh, that's right. Google.
We do have the internet.
What's the word for that when you see a word and you don't know if it's right?
There's a word for that?
Yeah, so like actual scientific word.
It's 2 L's? Thank you. I am sort of a grammar freak, so. All right. Milli and then micro. What's micro? 10 to the minus 6. Symbol there is mu. And then after micro comes nano, 10 to the minus 9, little n. Sometimes the micro is called a micron. Okay? So that's very common. All right. So have that on your cheat sheet, right? I went a little bit soft on the 4A students on their first exam. Some of them asked me how many centimeters are there in a meter. And I kept a smile on my face, but I did die inside. So. All right. Okay, so have that on your cheat sheet. Okay, chapter 23, sort of like some key equations.
Oh, is Pico going to be on this?
We will eventually get into Pico. These are the ones I expect you to know. Yeah, like Pico, I wouldn't be. I would tell you what Pico is, 10 to the minus 12. It's not a common one, even though we might go there. All right. So chapter 23, and then based on the topics list, which I took down from the screen for you. Where's my topics list? Right there. So let's see. We got integral setup for electric field. We've got charge distributions. We've got arc of charge, and we've got E equals 0. So in no particular order, let's do arc of charge. So somewhere in the class notes, there's the ring, there's the disk, there's the perpendicular arc of charge. Okay, so got this whole page of notes on the arc of charge. I've got all the stuff on the iPad. I can go look it up if I wanted to. So I'm looking at all of this, right? And it looks like I could write down everything on my page here, right? But all of that's not going to help me. What's going to help me is that the electric field, according to my notes, right, for an arc of charge, the punchline, as it were, was K lambda all over the radius of the arc, integral theta 1 to theta 2. And there's a minus sign out in the front. Cosine cosine theta I hat plus sine theta j hat. That's what I've got written down in my notes, d theta, right? Now, for me, I would leave it at that, okay, and move on. But you don't have all the experience I do, right? So it might help to have a picture maybe, okay, of what these thetas mean. Do you remember at all what theta 1 and theta 2 meant? Yeah, you do? What it like the angle where it starts and the angle where it ends, right? So I can give you any angles around a circle, okay? And you just plug in those angles, do the integral. So do you need to know how to integrate sine and cosine? Yeah, right? Now, there's going to be that integral table, which has the integrals of sine and cosine on it, right? So you can either write down some quick integrals on your cheat sheet, but I do have that integral table for you. And it'll just be attached to the back of the exam, right? So again, a picture, some definitions. One thing that students always mess up on the test, and I do take off points for it, is they confuse, like in this case, lambda for charge. Like the problem might say 10 coulombs of charge are put on there. And then the student will go ahead and go, oh, lambda equals 10. Does lambda equal 10? No, what is lambda? It's charge per length, right? So if you have a quarter of an arc, let's say, what's the length of that? If you have a quarter, like let's say I told you from here to here, right? And you need to figure out lambda. Well, that's going to be charge divided by what? The arc length of that thing, right? Okay? Whatever the radius of that thing is, times, and what's the angle here? You can't be degrees. You have to put it in as radians. Okay? So just remember, just be careful about lambdas versus q's, right? It's very easy. You're going fast on an exam. You read it, oh, lambda's q, go, right? It's not. It's charge divided by length. And for an arc, you have to use the arc length there, okay? So again, maybe your cheat sheet's going to have some notes on it that says, hey, watch out for lambda or something like that. You know your brain. You know what you're used to. Try to put yourself in a stressful testing environment, and then think about the things that you might want to have, notes on the page to help you remember what's going on. So that was arc of charge. E equals like, equals 0. Again, sort of that picture I just drew on the abomination about, charge can't go here, but it could go here or here, depending on the nature of the charges. Maybe a copy of the work that you did on the homework problem for that one.
Is it always going to be bound on the x-axis?
It could be on the y.
But like nothing like...
Yeah, we'll go. And if it's at some angle, you just rotate everything so that it's all one dimension,
Okay.
regardless. And I'm not going to try to make it too hard on you. So I don't know. Figure out what you want to write down for that one. Okay. And then what was the other topic? Integral setup. Good grief. What do you write down for integral setup? That could be like anything, couldn't it? Okay. So, and you could fill your cheat sheet with everything. For me, I'd probably write something like E equals integral dE, and then dEk dq over r cubed, r vector, where dq is equal to either lambda dl, sigma dA, or rho dV, right? And then like dA, boy, that's usually like a 2 pi r dz, like for a cylinder. For the surface area of a sphere, it's complicated. For the volume of a sphere, pi r squared. What did we do? Pi r squared d r cuts it into, no, it's 4 pi, the surface area times, yeah, there we go. That's the onion, right? We had a lot of different ways of writing down differentials, right? The thing that goes inside of the integral. And so if you can remember and write down all of the different ways, like for cylinders, for spheres, lines are pretty straightforward. You just cut it up into dx's or dy's or dz's, whatever direction you're going. But having some of those differentials down. As you can see, I'm just kind of barfing stuff onto the page here, right? Okay. And I do have the advantage that these are electrons, so I can just, fix stuff wherever I need to later. When I did it on paper, I would always barf it onto the page and then make a neat one later once I had everything kind of there. Am I doing it wrong? Some of you are pointing. What's that?
They're probably just trying to understand.
Yeah, there's nothing to do. The thing again, the problem in this is my brain going onto the page, right? Okay, and I can look at something even if it's like wrong and see it, and it jogs the memory in my brain of what I should be doing, and then I freewheel from that. So, it's again one of the reasons I don't like to come up with cheat sheets. But the takeaway from this isn't necessarily what I'm putting on the screen. The takeaway is the process, right? Sit down, do these kinds of things, go over your notes, go over the book. Based on the topics list, try to decide the kind of things you'd want to have to be able to refer to on the exam. So that would be, we did arc, we did integral setup, electric field of a charge distribution, line, ring, disk, etc. So there we had some very definite things. The book had them. We did a bunch of them together. So like the electric field of a perpendicular bisector. Oops. So perpendicular bisect, I should probably label all these a lot more carefully too. The electric field along that y-axis was KQ all J over y square root. And so now if I get a perpendicular bisector, do I have to reinvent the wheel? No, right? I don't have to worry about that integral or setting it up or doing anything. I know that the point, right, the picture of this is like this, and we write in half, and the point was a distance y, and like it had a length from like negative a to a. That's my picture, right? But what if I give you a problem where it's a perpendicular bisector, but it's going this way? It's the same equation. It's just your y is going that way, right? And you're like, oh, that's x. Okay, fine, it's x. Write it down as x. I don't care. The math is identical, isn't it? The result is identical. And that goes for rings. It goes for disks, right? Even though I might have drawn it along the horizontal. You had some homework where it was along the vertical. Same difference. Turn your head 90 degrees. I don't know. Mathematically, it ends up being the same. So there's the perpendicular bisector. Let's see. We got the ring. And all my bad handwriting here. Let's see. Electric field of a ring was K x I hat all over big square root x squared plus a squared cubed times q. And again, it might be handy to have a little picture, right? This is the point, and it's a distance x away. And in this case, the radius was a. So for the disk, I got thank you. Let's take you out this way. Maxine, you can come this way. Is there room? Did you move your bag, Rose? Yeah. Okay. Thank you.
Thank you so much.
You're welcome.
Have a good day.
So it's along the axis. Oh, the disk. What did I write down for the disk? I had, oh my gosh, 2k. So glad that I don't have to reinvent the wheel on the test, right? 1 minus x all over x squared plus r squared to the 1/2. Close it up. Pray that I wrote it down correctly from my notes. You don't want to know the number of times I wrote something down wrong on one of my summary sheets. Yeah. If I could just have those points back. 2k sigma pi. 2k sigma pi, yep. Sounds like a sorority or fraternity, doesn't it? 2k sigma pi. Yeah. All right. So we've got the disk, we've got the perpendicular bisector, we've got the ring, we've got the arc of charge. I'm not going to write some of these down, but like I've got the infinite line of charge. You know, just if we developed it, write it down. Right? From chapter 20, so in chapter 21, I did a bunch of the charge integrals, like integrating charge. You're going to need to integrate charge in chapter 23. So you might want to just kind of go back and jot down some of the, again, the spheres and things like that. Let's see, was that the topics for, is this helping? Or is this just boring? Because I can do stand-up comedy. Yeah.
For the bisector, right outside the square root, is that a y?
Yeah, it's a y. I'm going fast and I'm writing messy. That's no excuse. I write messy all the time. It's a y. Yeah, it's not a g. You should go look at your notes. How much sleep did I get? Not very much. I'm on muscle relaxants too, so this is really fun. Yeah, I committed the sin of going to sleep Saturday night and woke up with a shoulder that hates me. So if I do that, it hurts a lot. It's like somebody just stabbed a knife into my shoulder. It's a nerve problem, but I had to take some muscle relaxants, and my brain has not been functioning since. Yeah, don't grow old, is my advice. That's not a threat. We did electric field of an arc, electric field, find zero, distribution. Okay. Gauss's law, find charge enclosed via integration. What do we write down for that? I don't know. Gauss's law. Gauss's law looks like this. Q enclosed over epsilon naught. And what does this side of Gauss's law always turn into? It's just E times A, right? Now, what's the A if it's a sphere? 4 pi r squared, surface area of a sphere, right? What's the area if it's a cylinder? 2 pi r L, right, for the cylinder. For the cube, it's just 2 times the area of a side, right? Or however, it's not just 2, right? We always did like straight line stuff, like in and out. You got to remember for a cube that you can have electric field coming in one side and going out the other where the flux is 0, right? Or you can have it just going out. In the shower problem, I think the electric field was going out 6 ways, right? So you calculate EA on every face and then add them all together, right? So for the cube, that's a different issue. Right? You do EA plus EA plus EA dot 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 for, you know, however many you need to do based on the electric field that you're given. But that's really, and then the electric field. So we picked up a couple more things in the Gauss's law chapter for like the electric field of a plane, like the thin plane. It was sigma over 2 epsilon naught for a thin plane. And the electric field was sigma over epsilon naught for a thick plane. Those were results that we got. All the other results we got were all the same as we had had before for lines and wires and things like that. What do we do about if we have to integrate the charge enclosed? Is there something already on the screen that's going to help me with charge enclosed? It kind of comes back to all these differentials, doesn't it? If we're going to find the charge enclosed, we're going to integrate little dq's. And then those dq's are going to end up being lambda dl, sigma dA, or rho dv. However way we want to slice up the charge that we have. What? You can't even, I mean, you can't read Greek and you can't read my handwriting. Again, I'm going fast and messy. That's a sigma. And so is the one above it. All right. What's the other one that was on there? Gauss's law, integral charge. Electric flux / Gauss's law, same, that's that. Find the electric flux. I do want to point out, if you are asked to find the electric flux of a given situation, flux can be calculated as the dot product between the electric field and the area. That's one way to do it. Or it's this integral, right? E dot dA. But should you ever be calculating this integral? No, we always turned it into EA and then found the electric field. If the problem asks you for flux, and you know how much charge is in a spot, how do you find the flux? What is this side? It is flux. I have students break themselves. They solve for electric field, and they're like, Mr. Bailey, you didn't give me an area or something. I'm like, but I'm asking you for flux. Gauss's law lets you find the flux by doing what? Charge enclosed divided by epsilon naught. Okay? So be careful. Know what you're being asked for, and realize you should never be doing that flux integral. And then finally, Gauss's law conceptual. What do you put on a cheat sheet for conceptual questions?
Do your best.
Right?
Got this, hang in there.
Yeah. Maybe write down everything you know about Gauss's law in a little spot on your cheat sheet. Or maybe put some copy and paste the homework conceptual question. Like, they're not necessarily going to help you, but they will help your brain get into a mindset for solving that particular problem, right? When it comes to conceptual questions, I'm not sure a cheat sheet's going to help, right? Conceptual questions always come down to what is your understanding. Let's face it, on a lot of mathy type questions, you can kind of fake it, right? Fake it till you make it. You know it's got to be this kind of integral, and I'm just going to kind of just do it and see what falls out, right? In 4A, it was always, well, just throw formulas at the wall, see what sticks, right? There's a lot of that happens in these classes, and we know it. It's okay, right? That's normal. But when it comes to conceptual questions, you have to understand the physics or not, right? And so, again, I never really worried about putting conceptual information down on my cheat sheets, unless it was something so weird that I knew that I still didn't know it, in which case I just tried to throw as much as I could on there.
It seemed like from the book, the conceptual questions charge as it relates to going through some kind of shape.
Yeah.
So like, is there something like that?
Well, we already kind of wrote down all the shapes, didn't we? Cylinders, spheres.
No, but like the perpendicular question that one goes through.
Yeah, well, that's part of the concept of what like electric field lines do. They're always perpendicular to at the surfaces of conductors and stuff like that.
Are we still gonna have to explain our choice?
Mm-hmm. It's really mean, isn't it? Not only do I want the correct answer, I want to know why you know it's the correct answer. This is the correct answer because I cheated. I looked at the neighbor. No, you can't do that. I mean, oh, well, then we have a conversation. I thank them for their honesty, and we figure out how to go from there.
What if you got it right, but you couldn't explain why?
Then you get it wrong. Yeah, no, correct answer isn't enough. Now, remember, you can always explain why the other choices are incorrect. It is quite often easier to do it that way than it is to try to explain why the correct one is right. I see your hand, Liz. Let's go here first.
Is each question worth the same amount of points?
Exactly the same amount of points. Lewis? Already forgot your question?
The grading thing.
Yeah.
Is it going to be about the same?
Mm-hmm. All right. So two topics have come up. How do we game the exam, right? And how is it going to affect me in the long run? That question I'm not really going to answer till till the Monday after the exam, right? The first exam autopsy is typically where I kind of talk about the scale, and it's not a curve, it's a grade adjustment. Those of you that had me before kind of know what's coming up. If you haven't had me before, they don't have any advantage, okay? All they know, well, let me ask it this way. Former students of mine, did I have your back? Was I looking out for you the whole time? Yes, right? Okay. So you can choose to believe them or not. If you're new to me, right? I go out of my way to give you benefit of the doubt. During the exam autopsy, guys, what were you allowed to do during that autopsy? You talk to each other, but also you could argue the point with me, right? And for some of you, I did it wrong. Like I graded it wrong. Like I missed things, right? And what happened if I missed something or didn't realize what you were doing? You got that point back, right? So you're going to have a choice. You need to put down everything that you possibly know on the page, right? Because some of you did come to me, Mr. Balogh, I knew this is what it was, but there was no evidence on the page. And what was my response? I believe you, but I can't give you credit, right? Because it's not here on the page. There was no evidence for it, right? So get as much down on the page as you can. During the autopsy, we can figure it all out, right? So I've got your back. I'm fighting for you. I'm looking for excuses to give you points, okay? So all of that is true. Now, strategy and gaming exams, right? This is something you should be thinking about in the context of every class, but I'll just tell you straight out how to perform best on my exams and the way I write them. Every question is exactly the same number of points. So what do you do with the hard questions? Do them last. Whatever problem is hard for you, and it's going to be different for different people, right? Do those problems last? Some people make the mistake of thinking you should do the hard ones first, right? Your brain is fresh or whatever. You sink too much time. 20, 30 minutes goes by, you're still working on one problem. You could have finished 3 easy ones in that same amount of time, right? On tests where like the harder problems are worth like 30 points and the easy ones are worth 5, you really can't do that, right? But I'm telling you, on my test, I designed it so that you should be doing the test out of order, right? You should be identifying the ones that you think you can answer really quickly and then going back and doing the ones that you think are going to take you some more time. Because, right, they're all worth exactly the same amount of points. My tests also, was there ever a question on my test last semester where if you didn't do number 4, you couldn't do number 5? No, they were entirely separate from each other, right? Brand new problem, brand new situation, whatever. So you don't have to work them in order. I always hated tests that were like, you know, you number 1, multiple choice, and then number 2. Based on your answer for number 1, you know, I'm like, oh my gosh, I'm dead, right? Okay, so, and there's virtue in that kind of questioning, but I'm not in physics. So work the problems out of order. Do what's easy for you first. This means or implies that you're going to spend the first couple minutes of the exam doing what? Flipping through, looking at all the questions, right? Making a note, like circling the ones you want to try to start right away. Okay, so you've started the exam. You're 2 or 3 minutes into the problem and you've gotten nowhere. What do? Skip. Go to a different question, right? If you are like halfway through the problem and you're just kind of stuck, what do? Go to a different problem. Give your brain a break on that topic, switch its focus to a different topic, and then about 3 minutes into that one, I wouldn't be surprised if all of a sudden you remember what to do on the one you were stuck on. Okay? So it requires a little bit of attention deficit disorder. Style of thinking, right? If you're getting stuck, don't waste time just spinning your wheels. Move on. Try something else. You'll bounce back to it. Okay? Why am I telling you all these things? I'm trying to get the best performance out of you I possibly can, right? So, short of just giving you all the answers on the exam, which isn't going to help you at all in the long run, okay? Knowing these things, right? How the sausage is made and what I expect and all that kind of stuff, hopefully is helping you feel a little bit better. Or is it just ratcheting up the anxiety? A little bit of both? Right? Okay. Those of you that had me before, like the difficulty of homework versus the difficulty of the problems on the exam, which was more difficult? Homework by a long shot, right? If you were like honestly trying the homework, then you got thrashed, right? And when you came to the exam, I know you felt thrashed. But after the autopsy, after talking about it with other people and going over it, you realize, oh, I was making some of these too hard, right? It's just quite odd. I mean, it's a good thing I don't ask you guys to grade your exams because you guys would grade yourselves much harder than I would ever grade you, right? So keep that in mind. I think after this long into my career, I'm getting pretty good at making sure that the exams are easier than homework. Does that mean exams are easy? Not at all. They're hard. And this is quite possibly the hardest physics exam you have taken. Why is it the hardest physics exam? This exam, why is it the hardest? The stuff is hard, right? The stuff we have learned is difficult and hard and mathematically complex and hard to visualize. You can't like see an electric field. It's abstracted stuff, right? It's not like the projectiles. We were able to watch that one in lab, right? Okay. So 4A, 4C, this is definitely the hardest. Okay. And your grade will be low. It always is. Okay. I don't know you, like, I can't predict your grade, right? But I can tell you, over the last 23 years, students always come out of this exam thinking that they need to change their major. They feel thrashed, you are thrashed, the grades are low. It's going to be okay. Lewis.
The test, like out of all the exams, like what would you rank it like?
It's the second hardest exam you'll take.
Just gotta do the same.
The third unit. So that's a little bit of a lie because students, so I would say roughly 33% of my students will complain to me after the third exam that they thought the first exam was the hardest. and the third exam was easier. The other 66% think the third one was harder. I think it just comes down to a person's brain and how well they're able to like visualize in 3 dimensions. Because the third exam we're forced into 3 dimensions. We got a lot of right-hand rules. Every question is conceptual. Even though we can math and do numbers, you can't do any of the math and do any of the numbers until you apply a bunch of concept first. So this exam right here, I should never say things like this. You could probably fake it with just math on this exam. Like I've showed you with like R vector, you could know very little about how electric fields work and still calculate an electric field correctly from scratch, just by following the algorithm, right, of using R vector and applying the charges correctly. On the third exam, if you don't know the concept, there is no way you're applying the math correctly. So some people thrive there. Like I said, 33% of people are like, oh, this is much easier. I'd much rather do it this way. And then for the rest of us, it's like, no, this is really hard. So it totally depends on the individual. But the first unit and third unit exams in this course are brutal, not because I sit down and talk to Mr. Woods and figure out how to make it the worst, right? No, it's just bad because of what the topics and the subject is. What's that?
Said I hope I'm one of the freaks.
Who knows? You should know, though, that knowing that the first and third are really bad, I've already told you about the second and fourth exams. What's going on with the second and fourth exams? They're a lot easier. In fact, I think they're easier than 4A or 4C exams. Okay? So, on average, right? On average, we're just a little bit harder than 4A. But it really is a roller coaster ride, and you have to hang on for the whole ride. Please note, I didn't say they were easy. It's still a physics exam, right? It's just they're easier than what you're about to experience. And grade-wise, your strategy should be to do what? I mean, the strategy is always do as best as you can on everything. But like, seriously, what are the tests that you really want to do good on? Second and fourth. Knowing that the first and third are really hard and you're going to do bad anyways, concentrate on the second and fourth and really try to get your grade as high as you can on those. Strive for perfection on the second and fourth exams. And that'll balance out any problems you have on the others. The wild card for this time around is it's a shorter exam. We're doing it in here for 70 minutes, and there's 14 points up for grabs instead of 12. So it's going to be interesting to see if those of you that have me before can give me some feedback and let me know if you like it better or worse than the way we did it last semester. Rose. Those of you that have me are laughing. Okay. Did I give partial credit? Kind of. It's entirely situational every single time. I do not give half credit for doing half of the problem. You don't get paid if you only built half a bridge or a building as an engineer, right? You have to finish the project. So, if you finish the project wrong, it's wrong. If you finish the problem wrong, it's wrong. The caveat is that on this exam, instead of being out of 7 points, it's out of 14. I'm giving 2 points per problem. So I have a little bit of a mercy point I could give. And I think the mercy point's going to be along the lines of, you didn't get the right answer, but you did set it up correctly.
So the process is right.
Yeah, give you a point, right? But again, if you only get halfway there, that's 0. Okay? How many of you have read my rubric? You're lying. There's no rubric. Okay? There's no rubric in the syllabus, okay? And that's for a reason, okay? It's because I feel trapped with a rubric. Okay, I really do. I think rubrics are good for essays, right? If you're grading like the written word and then like the rubric can say, you know, had good punctuation, good grammar, had a good argument, blah, 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 right? That's where, but maybe you had a good argument, but all your grammar was wrong, right? And then points off. But in physics, I mean, the rubric is do it right. You get a point. If something's wrong, you're wrong, right? So, yeah, right? Like
Get the answer right.
it's binary. It's on or off. That's all it is, right? Okay. So I do have, and I think the 1 point really is subjective. Subjective in the sense that I have to determine. Okay, is there a point worth of stuff here? Okay. For some of you last semester, do you remember? Like I would give you a mercy half point if you had another one that was also kind of a half point, right? And I'd say, both of these you kind of got most of the way there, so we'll give you mercy point. Basically, the mercy points are built in now, right? Because I can give you a 1 out of a 2.
So I'm assuming that means you're going to pay a little bit more attention to the math?
No. I don't like math. So Ramsey's question, those of you that haven't had me before, listen up. When you had me before and you made a arithmetic error, like you were going through and you had it all set up correctly and then you failed to carry the 2. Or I could tell that like your calculator, you messed up in your calculator. How many points, would I take all the points off? No, what would I do instead? I would say calc error minus 0, which meant you got all the physics right. Something's gone wrong in here because you did not get the answer I got, but I don't have time to go back and figure out why.
So like rounding
It's me being lazy. I don't want to go into the nitty-gritties of what you put into your calculator. Okay? No, I am doing that. So if you did the problem right, and I can quickly say, there's got to be a calculator in here somewhere, error in here somewhere, you get 2 points. Okay? Right? But the 1 point, I would give 1 point for like setting it up and then like not attempting the math or something. Does that make sense?
Right, there was times on the homework where I was getting like 0.53 and the answer was 0.51.
Well, that I just don't even bother to mark. I just like, yeah, you got it right. I move on. I focus on like the setup. Like, show me what you know.
So like you get 1 point for the physics being set up, and then you just for some reason stop and don't.
Stop, go and go halfway. Yeah.
That would be 1 over 2.
It might be 1 over 2. To be honest with you, I don't quite have it in my brain exactly what a 1 out of 2. And I think it's going to depend on a per problem basis. So like on the conceptual questions, there are choices. This is always true of every conceptual question. There are choices that are so wrong that instead of giving you 0, I'd like to give you -2 for picking that one, right? No. That's what the SAT does, by the way. Yeah, did you know that? A lot of these standard, the ACT, the SAT, which nobody takes anymore, right? If you pick the wrong answer, depending on the wrong answer you chose, they take off more percentage points than they would otherwise. Yeah, it punishes guessing is what it does. In physics, in the questions that I write, a lot of the, I'm targeting specific misconceptions that you have, and so I'll put the misconception in there as a trap, right? Have you learned to get beyond the misconception? And so if you pick the misconception, that's like 0, right? But what if you picked one of the answers was like half right? Okay, there's the correct answer, then there's like a couple of them that are half right, half wrong, and then there's one that's like really bad wrong, right? In my mind, I would probably grade one of the wrong answers that's half right as a 1 out of 2 in that conceptual framework. But then later on a Gauss's law problem, I probably only give a 1 out of 2 if you got most of it right and didn't finish your math or something. So it's going to depend on a per problem basis. This is the problem with me publishing a rubric. I'd have to publish a rubric for every single question. And I just can't do that. All I can ask you is to trust me that I am on your side. You guys agree that had me before? I am on your side. And I encourage you and welcome during the exam autopsy for you to do what? Fight for it, right? Call me out. Say, Mr. Balogh, I think you graded this wrong, or this is what, right? Ramsey hits me, but he's the only one.
Whoa.
No. Yeah, don't go key my car. Don't visit me at home with a baseball bat, right? Just, I welcome you to grade me. If you feel like you have been graded unfairly, what should you do?
Speak up.
You can go complain to my dean. It's fine, okay? Yeah, Miss Shirley. Oh, you've been there, okay. You can do that. She'll just turn around with you and come find me, and then both of you can beat me up. But during the exam, beat me up. During the exam autopsy, beat me up. Like, fight for it. I will not think poorly of you. As a matter of fact, I'll think better of you, right? So, and we'll talk more about that later. Boy, we talked a lot more than I thought we would about lots of different things. Yes?
In terms of conceptual questions and explanations, how on our lab you had us explain things with like the flow of charge versus the actual transfer of electrons, will you care on a test to explain it more?
Unless I tell you to specifically use like the charge model, but I usually don't do that. If you want to do it with deficit of electrons, I might think less of you, but other than that, no. It will, honestly, when I grade your tests, I flip the front page over so I can't see the names. And then I grade. So I don't know if it's yours or not. That way, I'm not grading based on if I like you or not or whatever. I like everybody, so. Those of you that had me before, what should we tell people? What haven't we talked about? Oh, asking questions during the exam, you're allowed to do that? Yes, right? If you're sitting there and you don't understand the question, you ask me about it, right? If you're sitting there thinking that there's no way that I would answer that question, what should you do? Ask it anyway. You'd be surprised, okay? If the question is along the lines of, Mr. Balogh, how do I do physics? I'll tell you. I'm not going to answer that for you, right? But then I'll probably try to help you steer your thought a little bit. Like, just ask, right? Just ask. At the risk of being offensive and not politically correct, let me just say, I know that there are cultures in this room where you are discouraged from challenging authority. Don't talk back to your parents. Don't tell your grandparents what to do. Don't talk back to a boss, whatever, right? Okay? I'm telling you, I promise you, I will not tell your grandmother. Okay? If you ask me a question, if you tell me I'm wrong, nobody outside of this class will know about it, right? I welcome you to talk to me. And I know you've had teachers that when you've challenged them, they have treated you very badly, okay? I am not that kind of teacher. Just ask anybody that's had me before, okay? Just ask. Ask them. Does Mr. Balogh yell at me for asking? No. Oh, I yell. Do yell. Have I told the story about when my wife came to drop off my lunch one time? No? Yelled at her. No. It was in a lab, and I had forgotten my lunch, and my sweet wife noticed, and she brought it, and she came in through the door, and I didn't even know I'd left my lunch, right? And she came through the door, and I was like, oh, Mrs. Balogh's here, and the whole class cheered, and I gave her an Oklahoma hello, which if you don't know musicals, you don't know what that is. It's a kiss where you take and you big swing. I was younger then. Yeah. And then I said, because I love embarrassing her in public, it's really fun, because she turns bright red. Anyway, I said, okay, class, you have 3 minutes to ask any question you want of Mrs. Balogh, and I will not intervene. Right? And so she was on the spot. It was half of a second. There was no delay. One of my students threw his hand in the air, didn't even wait to get called on, threw his hand in the air and said, does he yell like that at home? I don't yell at home. I just don't. I would yell to call the kids down for dinner, right? But that was a loving yell, right? But I yell because I get excited. I never yell because I'm angry. I never yell like at people, right? I'm just yelling because what I'm talking about is fun and exciting. And what's that? It's just a thing. Yeah. I'm known in the other building as being the loudest. Me and Mr. Johansson are fighting for the loudest teacher award because people could hear me all the way up and down the hall. They put the lecture rooms at this end of the building on purpose, right? And then they assigned me this room. They're like, I actually prefer the old lecture rooms, to tell you the truth. I know this room's nice and all that, but I think I like the old one with the heads in it better. It's laid out better and the desks are better. Anyway, but yeah, I think they put them on this end of the building so that they wouldn't have to hear me yelling. You need yelling in physics. It's true. All right, Monday, what's going to happen? We're going to finish the homework. You can ask me any questions. Tuesday, what are we going to do? You're going to ask me whatever questions you need to ask to be set and ready to go for the exam on Thursday, right? You're welcome. I'm not sure what I did, but okay.